I think in the last decade, we've seen sort of this rise of data infrastructure companies. And then I think the next sort of frontier of this is really going to be around the quality and the trust in the data that's powering those. If you think about, sort of our many of our customers, like I've invested so much in making sure that I have, the best infrastructure and the best team and the best people, and I'm setting up everything that I can. But at the end of the day, if the data itself that's powering the systems cannot be trusted, then what are we doing here?
Hey, welcome to this edition of the Data Nerd Herd. I had the opportunity to chat with Barr Moses, the CEO and co-founder of Monte Carlo. In this episode, we talk about data observability, data reliability engineering, the founding of Monte Carlo, and much more. This is a wide-ranging discussion, and I hope you enjoy it. Thanks.
Barr, how's it going?
Great to be here, Joe. How are you?
Good, thanks. So today on the Data Nerd Herd, we have Barr Moses. For people who don't know who you are, do you want to give a quick intro?
Yeah, for sure. I am the CEO and co-founder of Monte Carlo, the data reliability company. And prior to Monte Carlo, I was VP operations at a company called Gainsight, where I worked with many organizations on helping them become data-driven, whatever that means. I'm originally sort of born and raised in Israel and moved to California, I guess 12 years ago now. It's been crazy.
Oh, wow.
Yeah, long time.
Interesting. Why'd you come out to California?
I actually came out for school. I was never, it was my first time sort of actually being in California. So I didn't really know what I was walking into, if you will. But I came out for school and had so much fun and never went back.
Interesting. Where'd you go to school?
I went to Stanford.
Okay. Small college. Nobody's heard of it or anything. Cool. And what'd you study?
I studied math and stats. And it was a really fun experience for several reasons. One is, sort of moved from the other side of the country, or the other side of the world, actually. I grew up in Israel. I was just in Israel. I was drafted to the military at age 18, just like everyone else in Israel. And immediately after that, I actually took a year off to travel and backpack. So I traveled for almost a year across South America, which was an amazing time. Really, feel super fortunate to be able to take that time and just travel and sort of see that part of the world and really immerse myself in that experience. And then came over to Stanford to study, which was a different kind of fun. It was sort of, at the time, I felt like I was kind of like in Disneyland, but for my brain. Like there were all these like different things that I could learn and get exposed to, which I was really excited about. And then, after that, my dad is a physics professor, so I thought that I was going to stay in academia and try to be a professor as well. But I had to sort of fail my dad in some way, and so this was my big, I'm failing my dad moment, after which I turned to business and actually I joined a consulting firm named Bain.
Small company, just like Stanford. Nobody's heard of it. So that's interesting. I mean, math and stats is a pretty interesting topic, right? I mean, it's an interesting major, I would say. What got you into that out of all the things you could have taken in school?
Great question. One of the things that I loved about Stanford is that you were able to not declare a major for a long time. And so you could actually try a lot of different things and experiment in true startup style, actually. Right. Reflecting on it today, I'm like, oh, that's awesome. You actually get to, expose yourself to different classes and different topics, and also different professors and different styles of learning. I think I remember sort of starting college and being super sort of excited about that. That I don't have to make a decision, actually, that I can collect data and then make a decision, which was awesome. So actually, experimented with various classes and various majors, and ended up sort of landing on this one for several reasons. One is, I just found it incredibly intellectually stimulating. It was also, sort of a major that allowed me to, it get an opportunity to also actually sort of combine both practical and theoretical work with statistics as well, which I really enjoyed. And I got to work with amazing people. One of my favorite professors was Percy Diakonis, who's a math professor at Stanford, and Susan Holmes, statistics professor. And so, I think kind of the decisions that I've made at the time and still today have to do with, kind of the topics that I'm really excited about, and then the people that I get to interact with that help sort of shape those decisions and those careers.
Interesting. And so you moved into Bain after that. What was that like?
Yeah. So joining Bain was a very big difference for me. I mean, we were working with corporate America, Fortune 500, and other organizations. That was, a great experience. First of all, to kind of, get exposure to like what folks in organizations like that care about. There's a couple of learnings that I personally had. One is, interestingly, a lot of the decisions in companies today, and certainly back then, were made based off of either very limited data or no data at all, which is kind of ridiculous and not surprising at the same time. Meaning oftentimes strategic decisions about businesses, like for example, if you're working with, I'll give some color. If you're taking sort of a leading retail company, and that company needs to make a decision about entering a new market. So for example, let's say they're selling mostly in the United States and they want to start selling in a different market. And so what is the data that they have to make that decision? Obviously, they can collect data about, sort of sales of other companies, or, there's lots of data that they could collect. But at the end of the day, a lot of these decisions are actually ultimately based on data that is often wrong, whether because it's sort of, it's not up to date, or it's collected in a way that doesn't allow for the data to be high quality, or simply there just isn't data about the question at hand. And so I, as someone who likes to base a lot of my decisions on data, that was a surprise for me to see how a lot of decisions and strategy are made without data, and a lot about based on gut and instinct. And the other big learning that I had from my time there, I was fortunate to work on a variety of different projects. And so, I worked across tech, software, retail, restaurant, food chain, really sort of a variety of different topics and businesses. And the rate at which I had to get, me and my coworkers had to get really smart on a new topic was very high. So within just a matter of a few weeks or a few months, there's a lot of information that you need to learn in a very short amount of time, sufficiently enough to have sort of, an expert opinion on something. And that was a great challenge for me, very fun one. And also, taught me a little bit about the value of sort of someone that comes in without preconceived notions, and going back to first principles. So in my day-to-day life, I like to go back to that and say, what would we do from a first principles perspective?
Interesting. I mean, how would you pick things up that quickly? That seems to be a skill in itself.
Yeah, it's really hard. Practice helps. You really have to practice. I mean, obviously there's, experts who do this for their entire career. But, I think it goes back to collecting a lot of data and all the information that you can, and spending a good amount of time sort of in that research phase. And also the other thing that we've really helped is thinking about how different people learn. So for example, some people learn purely by reading. Other people learn by actually doing something and trying to solve a really hard problem with it. I learned by talking about it with other people. So by interacting a lot with other folks. So, something that we did back then and something that we do today is focus a lot on transparency and visibility into learning. So I'll give you an example. If I was on a call with a customer today, a customer said, I really care about something XYZ, and I think this is really important because of these and that reason. Like, let's say someone tells me, we're rethinking the structure of our data organization, and, rethinking titles, and, we're thinking about data more as a product. And so we're going to orient around that and hire data product managers. and we're sort of really moving towards that, then that's something that's can be incredibly helpful for a lot of other folks. And so it's sort of obvious, but actually taking a couple of minutes to share that with the team or share that with other folks. If we do that systematically across the company, we're actually able to learn faster as a group. And so at Bain, as an example, if you kind of get up to speed on a new topic, we'd share between us, hey, like I found this really interesting trend. I thought there was an interesting point, and kind of learn. So I think when folks put effort together, you can amplify or sort of accelerate the speed of learning as a group.
That's interesting. I mean, we'll get to Monte Carlo in a bit, but I think that's something I've been working on too. Is I think overly communicating in a lot of ways with my team. Just because I know what it's like to be in the other seat where you don't know what's going on, or you think you know what's going on, but you feel like you don't have a complete picture. I mean, is that something that you do at Monte Carlo as well? Then, I mean, you took maybe that practice and I guess use a communication style with your team there.
Yeah, we think about that a lot. It's actually, a topic of a heated discussion at Monte Carlo today, and I think for a few reasons. One is for us at Monte Carlo, like the company has changed a lot in size, right? And so we've grown significantly in the number of people at the company. The other thing is that I think the way in which people communicate has drastically changed in the last couple of years. Obviously, with COVID-19 and folks working from home, I think there is, on the one hand, fatigue from meetings and fatigue from Zoom calls, but also a strong desire to feel connected. And oftentimes, the desire to feel connected is related to how much information you have about what's going on, and are you in the loop? And I think that is very tied to, do you feel like you are socially a part of a group? Which at the end of the day, I think we all want to feel, we all want to be the cool kids, right? Or, and so I think, at Monte Carlo, we need to, as a company grows, we need to rethink how we communicate. Oftentimes, I don't know about you, but like most teams that I speak with are just on Slack all day, and you just have like 100 different pings, and you can't really figure out like what's going on and what Slack channels should I actually read and not. So I think folks are trying to figure out what's the best medium for that. We certainly are very intentional, so we're actually writing sort of a communication memo or communication policy, if you will, which is, here are all the ways in which you should stay in touch or be informed about the company, all the ways in which you should be in touch with your manager and your team, and all the ways in which you should be communicating on your own and learning. So sort of think about it on three different levels. I'm excited to see some of the innovations in this space, and I'm hoping that as we transition, we'll sort of be in kind of this hybrid state where we both communicate really well on Slack and email and other mediums, but also can meet in person every once in a while to kind of solidify those sort of social bonds, and that ultimately actually lead to folks working better together.
Yeah, that seems to be definitely the crux right now, I would say, about any company or team, is how do you work better right now, right? And I kind of want to ask you about that. When you first started Monte Carlo, maybe walk me through that whole genesis, like, not just talk about what gave the idea for the company, obviously, but talk about too the early days. What was that like? What kind of team were you looking to build?
Yeah, for sure. So I was previously at a company called Gainsight, created the customer success category. And I was very fortunate to work with amazing people there and learn a ton from them on sort of company building and category building. And when I left Gainsight, I knew I wanted to sort of start working on sort of building a company. But I think like many founders, I wasn't sure what idea to start out with. And so reflecting on sort of problems that I personally had, I sort of remembered the problem that I had back in 2016, where me and my team were responsible for data that folks in the company were using pretty regularly to do cohort analysis and churn and segmentation and make decisions about our product. Ultimately, the data was wrong often. And I would be the last person to know about it, which is embarrassing to admit, but is the reality. I would wake up on, a Monday morning or maybe Friday at 8 p.m. if I was so lucky, and someone would ping me saying, "Hey, what's going on with the data? The report here looks off." Or,
oh, yay.
Does that sound familiar?
Yep.
So, as a person who's sort of responsible for that, I think there's like two issues. One is data actually being wrong, but then the second is, why am I the last person to know about it? Can we change that? Assuming that, no one is going to say my data is 100% accurate. That's not really a reality that I think we should strive for. We can make improvements, but I don't think we're going to get to that. We can strive for a world where we're actually being proactive about this and we're not surprised by data being wrong. And so we actually hacked together a solution for this back at the time. And so when we started the company, I actually, that was one of the ideas that I was exploring. I explored this alongside a few other ideas. And what I did was I actually cold called people in the industry, mostly folks in data roles, and asked them what's top of mind for you. So literally, what's keeping you up at night? And, yesterday when you got really pissed off, what was that about? And also, if you had a magic wand and you could solve whatever problem you had, what would you solve? And so that was, very much sort of an exploration phase of seeing what do folks care about and why. And I noticed then when I was talking to folks about, this problem of data being wrong and not being able to know about it, people nod, sort of you did before, they're yep, that's my reality. Welcome to my day-to-day. This is what it looks like. And so this is a problem that just truly resonated with people. And it was incredibly personal to folks and to their job. And so, I was just thinking about how crazy is it that we, as an industry, don't have a way to know when data is actually accurate? And spending more time thinking about that, and also with my co-founder, Lior, we were talking about how software engineering, it's not a solved problem. There's obviously very strong developments in that space that allow software engineers to make sure their applications are reliable. Solutions like Datadog and App Dynamics, which, you would be crazy to run an engineering team without something like that. So what are we doing in data? Why don't we have something like that to make sure that data is actually as reliable? In fact, I would say that most or more and more of our applications will be, in fact, driven by data. So for example, Netflix was down for 45 minutes because of duplicate data. 45 minutes is a long time. It's a full Squid Games episode or something like that, which we could have been watching. And so when you think about sort of, it's duplicate data, it's a problem that everyone has. So why aren't we taking those concepts and adopting them here? And so, with that sort of notion, we couldn't believe, or I couldn't sort of see that a world in which we don't have something like this. You sort of get this kind of conviction through talking to folks, this is going to be a problem that's increasing its importance. Data is becoming more and more critical in an organization. More and more people depend on, rely on, and use data. And so the question of, can I actually trust this data, is going to become more and more important. And that also felt like a problem that was worth for us to commit ourselves to a journey of, hopefully a long journey, to actually solve this problem. And so we sort of coined our mission, or phrased our mission, to accelerate the world's adoption of data by reducing what we think is the number one barrier, which is data downtime. So that's really what we've been centered on. But, in the very early days, people would ask us, what does data observability mean? Mm-hmm. It's a word that's really hard to pronounce. Are you sure you want to use that? And I was like, yes, you're right. It is. But that's what we're hearing from our customers. And that's, I think more than anything, in the very early days, we spent as much time with our customers as we could. In fact, that's what we did. So we started the company, and for the very first month, we did not write a single line of code. We just spoke to as many customers as we could. And learned about what keeps them up in mind, and what is one meaningful problem that we can actually solve them. started with that.
What was the MVP like then that you built?
Yeah. So, it's a good question. So, first of all, we built an MVP pretty quickly. I think this was like within 6 or 8 weeks
Nice.
from the beginning. We wanted to get an MVP sort of in the hands of customers as soon as possible. And what we did, I mentioned before we actually started developing the product, we spoke to a couple hundred of data organizations, and really ranging from tiny startups to mid-market to large organizations who largely build in-house, companies like Google and Facebook or Meta, and Uber and whatnot. And we basically, through those conversations, kind of created a database of all the reasons for why data goes wrong. And how did you find out about that? And so a very common story would be, someone upstream made a change to the website or something else. Then that resulted in, a way downstream report that was out of date. No one could tell it. No one could see that it's out of date because there were no checks or nothing like that. But the numbers still show up, but they're obviously wrong, not up to date. And so that resulted in, a marketing campaign that we had to be, completely off, for example. And so, we collected, why does data go wrong? How do you typically find out about it? Like, what are the symptoms of it? And then also, what do you do to resolve it? Like, who do you involve? Who needs to know about this? How do you do impact assessment? So for example, if a certain table is not getting updated, how do you know if that table actually matters? Maybe you have 50 tables that are not getting updated. Are they all equally important? And we also, ask folks, like, how do you do root cause analysis? Like, how do you actually figure out what was the problem? And so we took all of that, sort of all of those learnings, in those early days, we documented every single conversation in an email and just send it to each other. It was a very non-scalable way. And we continued doing that until very late. And my team sort of told me, like, okay, I think it's time for us to stop documenting everything in email. There's, Google Docs, or better yet, something like Salesforce, or, other ways to sort of manage this. So at some point we graduated from that, but in the very early days, everything was documented in sticky notes and in emails and things like that. And so, as we sort of created that, that database, if you will, kind of knowledge about data downtime, data reliability, we've come up with actually the definition of data observability. So maybe I'll just take a step back for a second and explain what that is. We very much, kind of going back to the analogy of, sort of Datadog or App Dynamics for your data. We believe that most companies today have this problem that we call good pipelines, bad data, which is the problem of, I've invested so much in world-class, best infrastructure, but the data that's powering that is actually often wrong. So I might have the best data warehouse, the best BI, the best ML, the best data lake, but the data itself that I'm using is often inaccurate, and I don't know about that. And the solution to that in software engineering is actually the concept of observability, which allows you to understand the health of your applications and your infrastructure and to manage that by observing the outcome of that system. And so what if we took that and applied that to data? And that's how you get data observability. Now, observability in software engineering is very developed, and you would know what to measure. There's a certain set of metrics that you would know to help you make sure that ultimately you have 5 nines of availability and you don't have 45 minutes of downtime like Netflix had. Now, in data, what does that mean? What are you actually measuring? And so through our sort of research and work, we codified these 5 pillars of data observability. And we believe that if you instrument, monitor, document, and actually have visibility into these 5 pillars, you can get a very strong visibility into the health of your data. So very briefly, those are freshness, volume, schema, distribution, and lineage. So these together, if watched, or sort of if monitored, should be able to kind of help you start your journey on what I'd call the data reliability lifecycle. There's sort of 3 components of the data reliability lifecycle. The first is detect, so actually know about problems. The second is resolve, so actually be able to resolve it fast. Oftentimes, data teams know about problems only months later, and it takes them weeks or months to resolve them. And then the third part of the data reliability lifecycle is the ability to prevent these issues to begin with. So if you've operationalized trust in a good way, in a strong, healthy way, where you've addressed the first two, you're actually going to be able to prevent data downtime incidents from happening. Our customers report north of 70 to 80% of data downtime incidents reduced as a result of that. So, this was sort of the vision that we set out, or this is kind of like the learnings that came out from those early days. Now, how do you build an MVP for this, right? It's going to take a couple of years. It'll take time to actually build this out. So we very much had that in mind, but we actually thought through, okay, the first step is to start with the detect from the data reliability cycle, right? Like the first step is actually being aware of those problems. And then from these 5 pillars, it seemed to us like freshness and schema were the two ones that would sort of give customers the most bang for their buck, if you will, meaning this would be the ones that would be most automated. We'd need as little information from our customer we actually don't need information from them to get that up and running. And we've actually found that both of those are often the culprit of data downtime problems. And so schema changes that happen somewhere that others are not aware of is a very good example of how data can go wrong. And data just not showing up or being very late is also another common reason for why folks have data problems. And so in our very basic MVP, we just looked at schema changes and just tracked sort of freshness of tables across your data warehouse. That by itself solved a significant problem for folks, which gave us the confidence and the conviction that sort of this broad vision that we had is something that we want to continue to work towards.
It's really interesting. Good insights too. I mean, I noticed that in the data world right now, we're borrowing a lot from software engineering. Rightfully so. I mean, there's a lot of awesome ideas, and I think a lot of hard-won ideas too. That software engineering just had to come up with because, well, if you don't, applications will break, and that's not a good world to live in either. So that's really interesting. Pretty original insights too. Walk me through this idea of, it seems to be kind of a new buzzword, data reliability engineering, because we don't have enough buzzwords these days. We need more. Yeah. So what are your thoughts on this concept?
Yeah, I mean, it's definitely sort of, again, drawing on what you mentioned, it's definitely part of this movement of adopting concepts from software engineering. So, the reality is, or at least in my opinion, is that the data industry is probably a decade or so behind software engineering in terms of adopting these, right? Yeah. And so actually that's great news for us. I think it's great news because it means we don't have to reinvent the wheel. We can actually, we know that something else works in DevOps or SecOps, and there's concepts that we can adopt that we know sort of make sense. One of those, concept is observability. We talked about another concept that's, sort of, again, I think we're seeing more and more of is data as a product, right? So as part of adopting these best practices, what does it mean if you actually think about your data as a product? What does that mean for your organizational structure? What does that mean for the type of people that you hire? For example, you might need a product manager for data. Another example sort of along those lines is what you mentioned, like actually having data reliability engineering or data reliability engineer roles. And I think that's sort of a corollary to SRE roles, right?
Right.
Site reliability engineers. And so we are seeing, a very increased emphasis for organizations on the trust of data. And let's just talk for a second about why. First of all, because there's way more people in the organization who actually care about data, like significantly more. 5 to 7 years ago, there was a very small handful of people and a very small handful of systems. And so everything was concentrated and centralized. And today, there is way more people managing data, and there's also a decentralization of data. And so folks, sort of realize that having one sort of team and a very long bottleneck of things doesn't often work. And so we're putting more and more data in the hands of folks. And part of that also includes empowering those teams to actually know, can I use this data right now? Is it up to date? Is this the right table? Am I using the right report? And so we need to empower those teams not only with the right tools, but also with the right roles and the right structures. And so as you think about, what that, as an example of what that means is, for example, putting together SLAs or contracts between different teams. So for example, in Monte Carlo, you can define specific SLAs for your data and define specific contracts between different teams so that your data engineering team can hold your software engineering team accountable for actually delivering reliable data on time. Oftentimes what we see is that there's like finger pointing game where there's product analysts and data analysts and data scientists and ML engineers, and they're all just like, oh, the data is late because of that. No, because of that. Instead of kind of having this blame game, what if we actually had a framework to communicate about what we expect from the data and how we hold each other accountable? So SLAs and contracts or sort of contracts that help us communicate about those. And so going back to your question, I think sort of, data reliability engineering it's exactly that. It's borrowing a lot of the concepts that we know worked for SREs and DevOps and implementing them here. That really takes, going back to that life cycle that I talked about, detection, resolution, prevention, we're seeing more and more folks making their way through this journey.
Interesting. I mean, what I also find interesting too is these ideas of ops from software. I mean, they borrow a lot from lean and supply chain, actually, from back in the day, manufacturing, right, which is interesting. And I was just thinking, as you're talking about ideas like value stream mapping, for example, just figuring out where your bottlenecks are, how long things take. Building trust as well, right? I think maybe there's more to be borrowed from these older ideas in supply chain than we've already discussed, even in software. When I think about in manufacturing, there's the concept of single piece workflow, for example, right, where you have less errors if you focus just on the pipeline from A to B. Don't try and do a million things at once, like assembly line fashion, right? Which tends to happen in some data workflows as well. But a lot of the big component of that making that work is trust, up and down that chain. I mean, so you talk about SLAs, for example, and I think that's, it's good to have that contract. How do you build the trust and the feedback with the teams you're dependent upon in order to reduce these errors and preferably get to a root cause of problems in the first place?
It's a great question. And I totally agree with you. Some of these ideas date even back. I think we're not saying anything too crazy. It's crazy that we don't have this yet.
No, that's what I find insane, actually. I mean, I have books on my shelf, The Goal, and so forth, and many other supply chain books. I read through them like, this totally applies to software and data. I don't know why we're not doing this. So.
Exactly. I mean, I think just to use sort of a maybe very simplified corollary, but if you were to take a car manufacturer and you were to sort of assemble all your different sort of raw materials to get started, glass and metal, whatnot, and then you have you can imagine you have 15 different stations, and then at the end, in the manufacturing, and then at the end you get a car, and how silly would it be if you just waltzed into the manufacturer, went into the car without checking anything before that, and just drove at 110 or something miles per hour. And then you found out that the windows break and, a bunch of other problems with your car. That's basically what we're doing with data. We're oh yeah, let's collect everything, put it through this transformation, move it around. And then let's just use it in the end.
No, it reminds me a lot of when you hear these horror stories of American auto manufacturers back in the 70s, they'd put the engine in backwards and other stuff. And they didn't care. They were just incentivized to produce cars. They didn't care if it works. I mean, true stories, go look this stuff up. It's crazy as shit, just some of the stuff people were doing. But it was all about incentives and outcomes, right? If you're incentivized to just produce X number of cars per day and quality is not a thing, it's who cares? Not my problem. It's the customer's problem. They're the ones who are at fault, actually. So they should learn to drive a car that has a backwards engine. So that seems to be kind of, I think, what we're talking about, though, where it's a similar mentality in data right now, where if there's an issue, it's well, you're just reading the report wrong, or it's almost like gaslighting the person who's using the output. And it seems similar now that we talk about it.
Yeah, I think it's similar, and I think you hit the nail on the head on what I think is a path to the solution, which is thinking about incentives and rules and definitions. If all I'm incentived on is that the job is completed, but I don't care if there's only null data or that the data is wrong, I did my job. The job's completed, but if we change the way that we think about what's important here and recognize that it's not just the job was completed, but it's the job was completed, all the data was passed, it's the right data, it's the data that we should be using, that's actually a definition of it. So that's not something that you solve overnight, but that's the kind of stuff that like SLAs and thinking about metrics can really help. So some of the metrics that that we work with our customers on measuring that helps change the discussion on incentives, change that dynamics. Or if you think about data reliability lifecycle, the first measure around detect is actually time to detection. So as a data engineering team or as a data organization, have we improved in time to detection? How long does it take us on average to find an issue? I'll be honest, most companies don't even measure that. So actually just starting to measure it helps bring surfaces. The second thing that we look at is on the resolve side, time to resolution. So oftentimes it can take weeks to replay the data, to figure out the root cause, et cetera, et cetera. So can you actually, as a team, are we improving on time to resolution? And then finally, just the rate of incidents overall and their severity. So are we seeing less, top priority incidents over time? Have we collected learnings about what are the main areas in which we tend to see more things breaking that are typically sucking up our time, et cetera, et cetera. So just getting smarter about our operations overall. And so, we're slowly seeing this move, but I do think that as a data organization, up until maybe a year or two, we could have kind of get away without doing this. Mm-hmm. I don't think we can get away without it anymore. Someone's driving that car and the window is breaking and you're going to hear about it. So you better take care of that right now and don't put that engine backwards because that customer is not going to learn to drive it backwards.
That's interesting. I mean, so we talk about metrics and things like data quality. I mean, what are some of the, we talk about freshness as well, and time to detect issues. But what do you deal with in a situation where maybe the data, it's arriving on time, it looks good, but it's actually wrong? Like I've seen this in my experience where it's been wrong for years, actually. Reports are being, generated off this. Decisions have been made. When people start using the words, it's directionally correct, right? The chart goes this way, sort of. What do you think of, how would you solve these types of problems where the issues are a lot more subtle?
Yeah. So maybe two parts to that, maybe two parts that we have to live with together. One is, I do think that there are some decisions where having data that's directionally right has to be sufficient. And going back to, my experience working with, making strategic decisions based on data, oftentimes in those situations, you just don't have data that's good enough, right, or you don't have data at all. And that can lead to the wrong decisions, 100%. But I think in many instances, the only way to learn is to make a decision, move in one direction, and then course correct. And so there are ways where we do need to take that in consideration. And maybe the second part of this is we should aspire to have data that we can trust and that's reliable and scalable and secure. And also, it's not a magical solution, right? So it's not like you turn on a switch, you have SLAs everywhere, everyone is like, it's working like a clock, 100% accuracy, right? Like there's really no magic solutions here. I think the positive thing is that as we make data trust and data quality a top priority for the organization, we can make strong strides towards making this a non-issue. And by non-issue, I mean something that is ingrained in part of our operations and part of our teams. Weekly syncs. We should be reviewing how have we improved in time to detection and time to resolution. It's something that on an ongoing basis we need to improve on, but there's no magic solution. If the data has been wrong for the last 3 years, you're not miraculously going to make it right tomorrow. And so I think, claiming that there's some like magic solution for everything, I would be the last to say that. But I do think there's been an insane amount of innovation and growth in this space. Data observability is an example of them, where we've just like the pace of innovation, I think, has outgrown some of the problems that we've been trying to work on. And so I'm cautiously optimistic that we can make big progress, not solve everything overnight. And there's still some decisions that we will need to use our gut, but I think we can get way better as an industry. And I think it'd be a shame if we don't do that.
Have you studied any of the practices from financial auditing?
Like what, for example?
Like just, reconciling transactions, looking at process flows and stuff. It just occurred to me, this might be sort of the next chapter of observability, is actually borrowing from accounting and finance, as awesome as that sounds. But I was just thinking of, dealing with auditors, as I have in the past, for companies, they do a really good job at going through the process by which you collect, use, record data and so forth. And these tend to unlock where like true data quality issues are in some places where like the data has been wrong for years. Here's why, that kind of thing. So just more of an observation and a blurt than anything else. But it seems like, if I look at how they've been doing things for a long time, it's something I think that the data industry could be, might take inspiration from at some point. Strange as it is to take inspiration from auditors, but it's a good profession, I guess. So
yeah, no, for sure. And it makes a lot of sense. Like, I think, finance obviously has been using data for a while, and, financial reporting has become more sophisticated and more evolved, and there's a lot more, to report on. There's way better tools also for financial reporting today.
Mm-hmm.
So 100%. I mean, we have, candidly, we have not looked into applying that, but maybe we should.
At some point.
Knows? Yeah.
I mean, it seems like all the good ideas, they come from everywhere else. And so you just apply it to your domain. That's how new ideas come about. I mean, speaking of kind of the future of where things are going, I mean, there's a lot of data companies right now, a lot of tools, a lot of options, and I think a lot of interest in data. Like, where do you see the world of data going over the next 3 to 5 years?
Yeah, I'd start by saying there's this massive acceleration in the last few years that we've seen. I think for a few reasons. Partly because of the rise of data infrastructure companies who have made it way easier to actually, work with data. So obviously companies like Databricks and Snowflake and Google and AWS, which have all made it incredibly easier for us to access data and to answer questions about the data. And the funny thing is that when folks want to answer a basic question, like how many customers do we have, or how much revenue do we have, most companies actually struggle with those very fundamental questions. And when you have sort of both of those things together, that there's a gap and there's a long way for us to go, right? And so I think in the last decade, we've seen sort of this rise of data infrastructure companies. And then I think the next sort of frontier of this is really going to be around the quality and the trust in the data that's powering those. If you think about, sort of our, many of our customers, like I've invested so much in making sure that I have, the best infrastructure and the best team and the best people, and I'm setting up everything that I can. But at the end of the day, if the data itself that's powering the systems cannot be trusted, then what are we doing here?
Right.
Like it just like makes everything completely moot. And so I think there's going to be a lot more reason for folks to invest in this and figure out how to do this well. The other thing is that data has just become a lot more important in organizations. Like I think, 5-10 years ago, we were like, yeah, we're data driven. We make a ton of decisions based on data. Actually, today, some of our customers measure what percentage of the decisions in the company were made based on data. That's a really powerful concept, and actually holds folks accountable.
Hopefully the data is correct.
That's right.
Okay.
Well,
incentives and outcomes, right? So
exactly. But that's exactly right. When it's important in an organization to make decisions based on data, the next question is, well, I do hope that the data is actually accurate.
Right.
Right. It's the obvious next question. And in today's reality, it is not.
Correct.
Yeah. And so we sort of live in a dangerous place, in a place where we want to be using data more regularly, but we also don't know that we can trust it. And so I do think, obviously that this is going to be a very important sort of wave of innovation that's coming. Other sort of trends that I'm excited about, I mentioned, sort of data as a product, which has to do with sort of applying concepts from software engineering, et cetera. Yeah. But I think that that will unblock a lot of the problems that we see, and sort of allow teams to also move much faster as they're sort of developing and bringing more data into products, not just decision making, right? So recognizing that the data powers decision making, but also obviously many of our digital products today. And then maybe I talked a little bit about sort of the concepts of data observability. Another concept that folks talk a lot about is sort of data discovery or data discoverability, which has to do with, okay, we have so much data. How do we actually know we're using the right one? Where do I find the specific asset, for example? And, we hear from folks that they spend significant amount of time on those questions. So I do think that's an interesting area to watch for sure. And then, not to throw in more buzzwords, but definitely data mesh is something that sort of, I think rise to the top in terms of kind of heated topics or topics that are sort of debated. So I think, I will say that more than anything, just super excited about how fast the market is evolving. I think it speaks to how important the problems are. So I just feel fortunate to be a part of this journey.
Yeah, same. I mean, I look back, I've been doing this stuff for almost 20 years now, and it's crazy. Yeah. Like way back in the day, data was not cool at all. Like it was the furthest thing from cool. And I would say around 2010, it started becoming kind of cool. And now it's got a lot of attention, right? So, with great attention comes great responsibility, though. So
that's exactly right. Yeah.
What I find interesting too is, a lot of the gains early on have been driven by data science and I think more recently data engineering. But I'd like to get your take on this too. When we talk about a lot of things you've thrown out, they're enterprisey stuff, right? This is stuff that larger companies would be doing and have been doing for a long time. But you had to have the budget, teams, everything else, to kind of get this going. But now it's democratized. Observability, data quality, discoverability, everything else. These are things that startups could do. These are things you could do on your laptop if you were weird and bored for some reason. But it's not the world of even 5 years ago, right? Even 2 years ago, it's changed a ton. I mean, what are your thoughts on this? I mean, what engineers, for example, they want to engineer stuff, right? How do you convince a data engineer to adopt these kind of more, I guess, enterprisey practices?
Yeah, I mean, I would say, well, a couple of thoughts. First of all, I'm not sure we should try to convince anyone of anything.
Yeah.
Like I think more than anything, like in today's world, folks are super smart and super sophisticated, and they, there's like, it's very easy to like obviously get information about any topic and get up to speed on it. And so oftentimes, like actually the answer lies with customers. So, or with sort of data engineers or engineers, like they know what they need, right? So I'm not going to claim to come in and sort of convince anyone or to tell them that I know how to do things better. The only thing that I can do is share, what's worked for other folks in similar positions. And I think, some of the concepts that we talked about actually apply to all sizes and stages of companies. So like data as a product, to your point, like you can get started with that as early as possible. And we're seeing more and more companies actually like, even if you're a 10-person startup, you spin up, Snowflake and dbt and Looker and you're off to the races, right? You actually don't need much to get going. And even in those instances, you still need to make sure that the data is accurate.
Right. I would say the infrastructure is almost underwhelming at this point, in the sense where it's so easy to get set up. Like you say, a few minutes, you're done. We deal with data engineering teams all the time, and they have a lot of questions like, cool, I just set this up. Like, what do I do next?
Yeah.
I don't know. What do you want to do?
Exactly.
What's your job description say? Because
Exactly.
I think they figured they'd be spending 6 months slogging through setting up a Snowflake and everything else. And I think that's almost the least of your worries these days. That's commoditized, in my opinion, at least, kind of end-to-end workflows and stuff. Obviously they'll keep changing, but for right now, like that's pretty table stakes. So
Yeah, exactly. So I think the question is more around what's the problem that you have today, and how can we help solve that? The problem is not, I want to set up Snowflake and Looker and dbt. The question is, what do you want to use that for? There's this gap between data and action or impact, right? And this gap is filled by answering all those questions, but like getting the data is actually, to your point, incredibly fast and easy.
Almost too easy, because it's dangerous, because I think it provides a false sense of security in some ways. Like, we got the data, like we're good to go. We're data driven now. We've got reports and everyone's using reports. And yeah, but to your point, it's like the raw ingredients it's like everyone builds really great stoves and microwaves now, but the food is still crap. So it's like you need to focus on that.
Yeah, I mean, there's also, thinking about the earlier stages, there's also a sense of false precision. Like you have 5 customers and and they're using the product, once a day. What does that tell you, right?
Not much, actually.
It's awesome.
Or it tells you they use it once a day.
Exactly. It tells you exactly that. It tells you that you have 5 customers using it. Doesn't tell you anything about like the future of how many customers you have or how they will be using the product or what features you should build. Mm-hmm. It doesn't inform on that. And so I do think that, it's very easy to get a lot of data, but to your point, you have to make sure the data can be trusted, and you have to make sure that the data is actually useful to you in making an impact or driving a decision or building a better product. At the end of the day, I think those are the things that we're sort of here for.
Right. Yeah. I'm excited to see where it goes. I have no earthly clue. I was talking to somebody, in San Francisco last week about this, because I made kind of the quip that I felt like the modern data stack wasn't that modern anymore.
Tell me more.
Well, it just feels like it's now a data stack like anything else. Because it's kind of joking. It was that the ML ops peeps. ML ops community, and I was kind of like, so what's the equivalent of like the modern data stack what's a modern ML ops data stack? And we kind of had a chuckle about that. And like, it just seems that area is so immature still that if you came up with it, I don't know that you'd want to put your name on that just yet. So, or you can, if you want to put a stake in the ground, I guess that's also a bold way to go about it. And maybe that'd be the smart way to do it. But then I started thinking about the modern data stack, and I was like, to me, that the whole, kind of just a diagram, right? Like the 5 Snowflake, Looker, like it's great. It's also, I think, doesn't represent where things are really going, or even where things are today, where I think to your point, you need to tack on these other things now, like observability, catalogs, all this stuff that sounds like almost like borderline, like flossing your teeth in terms of like excitement, but needs to be done if you really want a good outcome. So to me, that feels more like what a modern data stack is. It's not just bolting together pipelines and storage and reports anymore, right? It's a lot more to it than that. So
yeah, I agree with you.
Might get some criticism on that, but whatever. I always do. So
I think we all want clean teeth, right? So
speak for yourself, Barr.
Fair enough.
Yeah, kind of switching gears a bit and closing out. I mean, we see you a lot on social media, and you obviously produce some awesome content and run a great company and so forth. Like, but what makes you tick? Like, what are you into outside of sort of the public eye and work?
Yeah, I think in my life, I love reading. I love meditating. Probably don't have as much time to do that these days. I just had I have an 8-month-old daughter. Her name is
Congrats.
Ray. Thank you. So I probably don't have as much time as I would like on meditation and reading, but I've replaced that with a lot of hiking, actually.
Cool.
So being outside has been really nice, especially these last few years. So that's been fun.
That's awesome. Wow. I don't know how you raise a small baby and run a company. That's cool. So I have 2 kids of my own. That's why I say that. So
cool. Yeah. I have an amazing team, both at work and at home. to make it
Hmm.
possible.
Yeah, wow. Hats off to you. That's insane. So insane in a cool way, of course, but that's so much work. That's really cool. Yeah, I think it's great for talk to different founders too, just to kind of understand what makes them tick outside of the work. Because I think it's that as much informs the type of founder that you are and the type of entrepreneur and business person you are too. Because everything you do outside of work, I think, reflects who you are when you show up, during the week. So
For sure.
that's really cool. And hats off for hiking too. We do a lot of that around Salt Lake, but that's because there's a lot of trails here. So,
Nice.
yeah, awesome. Well, cool. For people who want to learn more about you and Monte Carlo, how would they do that?
Yeah, feel free to check out our blog. So we actually write, as you mentioned, write quite a lot. MonteCarloData.com is the best way. And feel free to reach out to me on LinkedIn if you'd like to connect. I always like to connect with folks one-on-one, if they have questions or disagree with something or are excited about something. This is the stuff that I live, breathe, sleep. Love chatting about this at all times.
One last question, by the way.
Yeah.
Where did you get the name Monte Carlo from?
Oh, great question. So I actually did or worked on some Monte Carlo simulations back in back in school, and so that's sort of the original where it came from. But also Lior, my co-founder, is also a Formula One fan, and sort of it all comes together ultimately.
That's awesome. That's a good backstory. Well, cool. Hope to talk again soon. Thanks for being on the Data Nerd Herd, and we'll talk to you later. So.
Yeah, thanks so much for having me, Joe.
Yeah, anytime. Thanks.